test, 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 test. I like testing. 100% code coverage. Cheese. No, Vincenzo lì. Can I start or should we wait a few more minutes? Okay. Good afternoon. My name is Lorenzo Bettini. I'm a professor at the University of Florence. I'm an Xtext committer. This is a joint work with Vincenzo Caselli and Francesco Guidieri from RCP Vision, a company located in Florence working on Eclipse technologies. We're all committers of the EMF Parsley project. Today I'm going to show you the EMF Parsley DSL, which is implemented in Xtext and Xbase, and I'll give you a few details about the implementation of the DSL. So first of all, EMF Parsley is an Eclipse project to quickly develop a UI application based on an EMF model. We have good defaults, but everything is easily customizable based on declarative customizations. And we provide an Xtext DSL to make the customization of the components even easier. We provide a few JFace and SWT components like trees, form, dialogues, editors, or combinations of them based on an EMF model, representing an EMF model, and a few project wizards to get started. So under the hood, EMF Parsley delegates by default to emf.edit, but all the customizations can be done in Java, if you want, using dependency injection with Google Juice. So if you're already familiar with the way you customize things in Xtext, in EMF Parsley is basically the same. We reuse the same infrastructure. And also declarative customizations are basically the same as in Xtext. You can do all these things in Java, but we also provide a DSL implemented in Xtext to make all these things easier. We are code generation oriented, so we generate the Java code. And we think this approach is better than a pure reflective approach, because with the code generation, you can debug everything if something goes wrong. With a purely reflective approach, you may have troubles trying to understand what's going wrong, okay? So the EMF Parsley DSL is based on the Java API of EMF Parsley. Is implemented with Xtext and Xbase. So first of all, who's already familiar with Xbase? Okay, not many, and that's good because I'm going to give you a few more details about Xbase. So it's interoperable with the Java type system, so you can access all the Java libraries of your dependencies. And it has nice IDE tooling thanks to Xtext and Xbase, including debugging. So you can debug the DSL directly thanks to Xbase. You specify the customizations in a single file in a very compact form. We will see a demo in a minute. And the DSL will generate all the Java artifacts for you and also all the Google Juice bindings. If you want, you can use the DSL together with Java code. So you can customize some things in Java and something in the DSL, and they work together. Everything is statically type checked. So if you try to access a feature, so here I'm using the EMF library example. So if you try to access a feature who's not present in the E-class book, you get an error from the compiler. And you also get a quick fix for free. So And that's important because you get most of the errors during the compilation, not at runtime. Thanks to Xbase, we have access to all the Java types according to the project dependencies class path. And all the DSL elements can extend existing Java classes. So they work together. And as I said, it's completely debuggable. So if you saw the talk this morning about tracing and debugging, in Xbase, you have it for free. You have automatic imports and quick fixes of Java types. And you have a complete JDT integration, so you can navigate to Java types from the DSL or accessing the Java doc of a Java class. Everything for free, thanks to Xbase. And a completely integrated building mechanism. So as soon as you press save on the DSL, all the Java artifacts are regenerated. And most of all, and I'm talking about this later, we also generate the plugin XML and keep it in sync. And all these things are completely integrated in the Eclipse building mechanism. So let's see a very quick demo, and then you can have a look at more extended demos on the Eclipse, on the EMF Parsley website. So let's create an EMF Parsley from scratch. We have a wizard for that. So we give it a name. We also provide a wrap version of EMF Parsley. If you're familiar with wrap, wrap allows you to easily port and automatically port an RCP applications to the web with single sourcing. So if you want to use wrap, we provide a way to do all the setup in your project to have single sourcing. So this project will work both on RCP or on the web. Then we have a few templates to start from. We have views based on selection or views based on resources. Let's pick one just to have a look. So it creates a project. It creates a DSL with a few contents. You can navigate, as I said, to Java types. So we can navigate, you see. And most importantly, there's a part in the DSL where you specify an Eclipse view part. From this part, we generate the plugin XML. And as I said, we keep it in sync. So if we change the name of the view to something else and press save, the plugin XML is automatically updated. So for the demo, we'll start with an existing project. This is one of the examples that shipped with Parsley, so you can import it in your workspace. This example is based on the EMF library example. So here we have many customizations. I won't have time to go into the details, but just to get started, we will comment all these customizations. We only leave a few things. And let's see what you get by default with Parsley. So let's start another Eclipse instance. And what you get for free is a view with a tree. And if you click on something on the tree, you have a form showing all the features. This is done automatically by Parsley by inspection on the EMF classes. If you change something, we have data binding, so everything is updated automatically. The view becomes dirty, and you can save it. We have context menu by default. These are the standard EMF menus, undo, redo. If you double click on something, you have a dialog where you can edit something. We also have automatic validation support starting from the constraints of the meta models. So in the book, let's open with the dialog. So the book has a constraint where the writer must be specified. If you don't do that, you have automatic error reporting, and of course the error goes away if you add the writer. So this is the default one. Let's say that we want to customize the content provider of these trees and show only books and writers and borrowers. We have a section in the DSL. It's just a matter of, in this case, we uncomment that. So we say that the children of a library node are the writers and the books. So if we want to see this in action, we should start another Eclipse instance. So a good thing of a code generation oriented approach is that you can debug everything, but a bad thing is that each time you have to run or restart the Eclipse instance to test it. So for this reason, we try to mitigate this problem by implementing a live preview. So this thing is a work in progress. It's experimental, and we still haven't released that. So you won't find that in EMF Parsley. You have to provide the injector provider generated by Parsley. And what we do in this case, if we click on preview, is that by using JDT, we dynamically load all the classes of this workspace and create all these things by injection reflectively. So in this case, you can see that the contents of a library has changed according to this specification. So we don't show the borrowers. Let's also show the borrowers. And if we save, press preview, we have live preview, and we also have the borrowers. Let's uncomment all these customizations, just to give you an idea. You can customize the features that are shown in the form. You can customize the orientation of the form, all in the DSL. So in this case, for a library, we only show a name. We have to show the section in the DSL. So for the library, we only show the name. For a writer, we only show the name, address, books. Another thing that you can easily customize in the DSL are the context menus of the tree. If you're familiar with EMF, you should know that it's not that easy to create new or customized context menus with the standard EMF API. With the DSL, it's just a matter of specifying that for a writer node, I want to create a new menu called a new book, and then you specify the actions in a lambda. And in this case, you don't have to worry about anything else. You have the new menu, and you don't have to deal with undo and redo, because we will deal with that automatically for you. So just specify the menu, and that's all. So this is just to give you an idea of the DSL. Let's get back to the presentation. So we achieved most of the things thanks to Xbase. And you get many things from Xbase for free as long as you use it according to its contracts. So now I'm going into some details of how you should use Xbase in your DSL. First of all, Xbase was introduced because with Xtext it was easy to do with it was easy to implement structural features of the DSL, but when it comes to behavioral aspects as like expressions, you had to do many tedious things manually, starting from the grammar and the type system and code generation. And especially if you want to target the Java platform, you may have to implement many things. For this reason, Xbase was introduced. Xbase is a reusable object-oriented expression language. You just plug it into your DSL, and you inherit all the syntax for these expressions. And what you get for free is, besides a Java-like expression language, a complete interoperability with the Java type system. So all the Java types will be automatically available in your DSL. And as I said, you also get debugger for free. So if you're not familiar with Xbase, but you're familiar with Xtend, basically Xbase has the same syntax of Xtend's expressions. So everything is more readable. You have lambdas, extension methods, and you can easily write these queries with lambdas and extension methods, which are readable, really readable. They read like in English. You see there are no types, because every type can be inferred by Xbase, but still everything is statically type checked. So as I said, you have to inherit from Xbase, and you get for free the parsing of expressions. But to have also the other aspects like the type system validation and scoping, you have to provide, let's say, some glue code for from your DSL to Xbase. And to do that, you have to implement a model inferer. So let's get into the details of that. Xbase implements a Java type model, which is a model that models the Java types like classes, interfaces, and enumerations. And it also models the Java type elements like methods, fields, and so on. This Java type model is automatically populated by Xbase with all the Java types that Xbase can find in the class path of your projects. It doesn't, all these Java types don't need to be available in sources because it can also deal with class files. So this is done automatically by Xbase. All you have to do is to make your DSL elements part of this Java type model. And to do that, you implement a model inferer, which basically, in this case, you have to specify how your DSL model elements maps to the Java type model elements. And once you've done that, you also need to connect all the Xbase expressions to a Java type model methods. Once you have this mapping, Xbase will be able to do all the other things automatically for you. It means it can perform all the type checking and all the type inference. And it also implements a proper scope for this and super. And it also generates all the Java code for you, only by specifying this mapping. So let's have an example from the EMF Parsley DSL. You saw the menu builder section in the DSL. Now I can specify a variable here inside the menu builder, and then I have all these things in the EMF menus section. And you see that from here I can access the variable. How do I achieve this? I don't have to implement any scoping mechanism. I don't have to implement any validation mechanism. I simply say that the menu builder element is mapped to a Java type model class. The factory variable is mapped to a Java type model field of this class. All the elements of EMF menus section are mapped to Java type model methods of this class. And then you have for free the scoping automatically. So when you use Xbase, if you implement the model inferer correctly, you won't have to deal with custom scoping. You want to use annotations in your DSL, you can do that by inheriting from this customized grammar as Xbase with annotations. In this case, you have a rule, an additional rule, X annotation. You can use that in your DSL. Then in the inferer, you have to map all these X annotations to Java type model annotations. And again, you get for free that these elements can enjoy all the available Java annotations of your class path. If you have to implement this mapping in the model inferer, you have to use the Xbase API for doing this mapping. To get started with that, you could use the domain model example that comes with Xtext that specifies entities and operations and properties. And I don't want to get into the details, but you find this example that ships with Xtext. Specifying this mapping is really easy with this API. You say that the entity is mapped to a Java class. Then inside this class, you can say that each property is mapped to a field. Each operation is mapped to a method, and the method can have parameters. You specify all the parameters. And then the important thing is associating an expression of the DSL to the body of the mapped method. And with this in place, Xbase will do all the other things, all the other magic, scoping, validation, type inference, automatically. I want to go into the details of another aspect of the EMF Parsley DSL implementation. And I think this question was asked even this morning. You saw that from a single DSL input file, we generate several Java files. and that's fine. You should never do the other way around. So you should never try to generate a single file from several input files, because you will get into troubles. But especially in EMF Parsley, we had a situation when we had to deal with this scenario. And the problem is the plugin XML, because in a project, in an EMF Parsley project, we can have several input files, but in an Eclipse project, there could be only one plugin.xml file. So we should generate a single plugin XML from several input files. How we achieve that? So in the end, what we want is that we have two Parsley input files with two view parts specifications in the same project. In the end, we want a single plugin XML. How we achieve this? We don't generate a single artifact by analyzing all the input files. As I said, you should never do that. What we do is using another step in the code generation. So from each single view part specification, we generate a single plugin.xml gen file. And then we have another custom Eclipse builder which takes all these generated files, and by using the PDE internal APIs, we merge the existing plugin XML with all this information. So there's another additional builder which is automatically triggered when a new plugin XML gen file is generated. And in this case, you won't have problem. But you need this additional step. You need an additional builder. At least that's what we needed in our scenario. Another thing that you get for free from Xbase is type inference. How can you really benefit from this type inference? Well, for instance, you saw in the example that we specify lambdas for context menus entries, and you don't have to specify the type of the parameter. So in our case, what we did, we defined a pure Java API using generics. Since we have this mapping in the model infer from DSL elements to Java type model methods, then Xbase is able to perform the type inference automatically for you. And it does all the matching between type parameters and type arguments. Let's see an example. In our case, we have Java API for the base class editing menu builder with a Java method action change, which is generic. Okay? So it has generics in the parameters. EMF menus, as I said before, is mapped to methods of a class which extends editing menu builder. So inside the EMF menus, we can call this method action change, and since the second argument is a library, then Xbase is able to match T with library, and then the library parameter is automatically instantiated with library, and you don't have to specify anything else. You have type inference for free, as long as you have a Java generic API. So I think I can conclude. As you saw, Xbase is not only parsing expressions. It's much more. It's a complete integration with the Java type system and JDT, and you have a powerful type system. But you have to remember to follow its contracts correctly. If you do that, probably you won't have to specify any other customizations. Well, if you start to do some very heavy customization in the grammar, then you may have to customize the type system, you may have to customize scoping. But in our case, the DSL is not that simple, it's quite complex, but we didn't have to specify any other customizations besides the model inference. Okay? So I think I can conclude. Just small advertising. You can find Xbase in a few chapters of my book, second edition. And for the conference, there are a few discount codes that you can enjoy if you want to buy the book. So please evaluate the session, and if there are questions, thank you for listening. Any questions? Okay, anything is clear.